Hello, and welcome to this tutorial on applying big data to next-generation analysis and closure. I'm Tom Fitzpatrick, Strategic Verification Architect here at Siemens EDA, and I'll be your main presenter today. I'd like to take a moment to thank my colleagues Darren May, Tom Ellis, and Athira Paniker for their help in pulling this material together. Okay, let's get started. Many of you may be familiar with the biannual Wilson Research Group industry study that's been led by my colleague Harry Foster for the past several years. One of the questions that we've asked every year is, what is your biggest functional verification challenge? And we've compiled the data going back to 2014. You can see that over the years, the answer from the ASIC groups has always been coverage closure, with a significant jump in the past few years. We asked the same question of FPGA groups, and wouldn't you know it, got the same answer. In today's tutorial, we're going to look at how you can get a better handle on coverage closure by gaining access to a wider array of coverage data, and most importantly, being able to turn that data into information that will help you not only know when you've reached coverage, but also help you to identify coverage holes and prioritize your efforts to close those holes as quickly and efficiently as possible. So let's think about a typical verification management project from a pain management point of view. I used to work with a guy who believed that everyone is motivated by pain management. Everything anyone does is either to minimize his own pain or to maximize someone else's. Let's go with the minimize pain approach for this project. The first thing we need to do is to identify the questions we want to be able to answer as we go through our project. Questions like, who is responsible for specific pieces of our verification plan? What are the risks we're facing? Which verification engines should I use to test this feature? Where do we start debugging? Why are we behind schedule? And I know you're all nodding your heads at that one, aren't you? But the two most important questions are, where are we in our verification process? And when are we done? But on top of that, we've got more challenges than ever. Most of us are working with colleagues across the globe, so we have to manage across multiple time zones. And with COVID, even our office mates are remote these days, often with people who have different skills and expertise, and who maybe are used to different methodologies or have access to multiple engines. And of course, we're all working under aggressive schedules too. So we're faced with the prospect of having to manage the data, the processes, and the tools we'll be using to be able to take all of this in and be able to automate our regressions, triage problems, and merge results from all over the globe in order to answer the most important question, when are we done? The key to coverage closure is data management. The first step in doing that is getting the data in the first place. And you can see here that our enterprise verification platform encompasses multiple engines, including, of course, our Questa simulator, Questa formal tools, and Veloce emulator, but also virtual prototyping all the way to FPGA prototyping. And by the way, simulation includes analog and mixed signal simulation too. On top of that, we layer what we call verification infrastructure, which includes our standard support for everything from System Verilog and VHDL through UVM, UPF, UCDB, and now Portable Stimulus as well. Given that infrastructure, we support higher levels of stimulus, debug, and process management and analysis without necessarily having to know which engine you were using at that bottom layer. So let's focus on that management and analysis box for a minute. The way we manage all the data we're going to need is through our Unified Coverage Database, or UCDB, which is at the heart of our verification management solution in Questa. It's also the basis for the Unified Coverage Interface Standard, or UCIS, from Accelera. By unified coverage, we mean that the database can capture coverage data from any source engine, and will help you analyze it regardless of where it came from. The point of today's tutorial is to show you how you can do this using Questa. The UCDB has been architected and continuously improved to provide unmatched performance and capacity. And we've built around it a comprehensive infrastructure so you have a unified environment for reporting and managing your coverage results. This lets you guide the process based on your requirements and your verification plan. As you'll see, we've integrated these together so that you can see where you are in your process and how you're doing compared to other projects to increase your predictability and optimize your efforts to help you reach electronic closure, where you know that you've really done everything you need to do. And the key here is that all of the data is directly connected to the tools, so it's not just a spreadsheet. Everything is recorded automatically. We've automated the regression process so that based on your coverage and debug results, you can easily rerun specific tests or groups of tests on whichever engine originally ran them. If a test passes, it's automatically put in the database along with its coverage results. Failing tests can quickly be triaged, debugged, and fixed. The automation means that you can easily and quickly identify the relevant tests, including things like the 10 or 100 tests that give you the most coverage, and quickly rerun them at the touch of a button, because we not only capture in the UCDB what your coverage results are, but everything about how the test that you got those results with was run, including everything down to the specific random seed you used, so that you can make sure that even if your test uses constrained random, the rerun test will actually make sure that your problem has been fixed, and will automatically balance the load across your regression farm so we can maximize the throughput and minimize turnaround time so you get through your regressions as fast as possible. So what we've given you is a bunch of building blocks that you can use to build your own environment if you want. There's a default flow you can use, but depending on your situation, you can customize it if you want. But as you'll see, up until now, this has mostly been a single user cockpit. As we saw in the previous slide, teams really need a collaborative environment that really lets them work as a team and not as a bunch of individual engineers. We'll get to that in a little bit. So what exactly do we mean by unified? Well, obviously we mean that all the coverage data is unified into a single database, and the engines are unified in that they can all create compatible coverage data. This has a lot of advantages for you, the user. Having a unified view of the tests in your test suite lets you use the verification run manager to manage your regressions across your regression farm, regardless of which engine you actually used to run the test. And you similarly analyze your results without worrying about the underlying engine either. But in addition to analyzing the results of a particular test, you can merge multiple tests and analyze the merged results. This lets you rank your tests according to how much they contribute to your coverage. This lets you do things like defining a check-in suite of the 100 tests that give you the highest coverage in the shortest time. And it also lets you eliminate running tests that don't actually contribute to coverage. Remember, a simulation cycle is a non-renewable resource. Once you use it, it's gone, so there's no value in running tests that don't contribute to coverage. And of course, we need to track all of this according to our test plan so that we know that we're running the right tests. I once was talking about verification with a customer, and I asked them if they used a verification plan. Now, I've asked this to lots of customers, and the answer is usually either yes or no. But this particular customer, who made wireless networking chips, gave me a rather interesting answer. They said, "We do now." I asked them what caused them to start using a verification plan, and they told me that on their previous chip, in all the simulations they did, they never simulated sending 2 packets in a row. Of course, when the chip came back and they plugged it in, it tried to send 2 packets in a row, and the chip hung. So now the first thing in every verification plan of theirs is send 2 packets in a row, and then they go on and test other things. Questa actually includes the test plan in the UCDB, so it can automatically correlate results back to your test plan for you. And by having all of the test results in the database, you can analyze trends over time so you can track your bugs over time and see how your coverage is doing and if it's leveling off or if you're still making progress. And we can also include your requirements in the database so we can correlate all of your results all the way back to your original requirements. Our rec tracer tool identifies each requirement and correlates it to an element in your design so you can track your RTL development against requirements. And it also correlates elements of your verification environment to determine if that RTL element has been properly tested to satisfy the original requirement. The verification element can be a test, or it can be a system verilog cover group, or an assertion, or a UVM sequence, or whatever you need it to be. Since everything is linked back to requirements, you have a built-in ability, if you make a change to your RTL, to know which tests have to be run to make sure you didn't break anything. And at the end of it all, you can relax in the knowledge that you've completed all of your tests to verify that your design meets all of the requirements that you defined at the beginning, or the requirements that got added along the way, which is always the bigger problem, isn't it? Of course, if you're going to analyze data to look at trends and merge results from multiple tests and correlate those tests with your test plan, you have to collect the data in the first place. Obviously, the first place to get the data is from your simulator, which we hope is Questa. Questa can automatically dump functional coverage as well as code coverage and assertion coverage into the UCDB. But one of the cool things is that we can actually look at the functional coverage results during compilation and elaboration to optimize the simulation to ignore cover groups and cover points that we've already covered, so you get a more efficient simulation to target the remaining coverage holes. When you include Questa verification IP in your simulation, you automatically augment your test plan to include all of the aspects of your specific protocol, but also all of the cover groups, cover points, and crosses needed to ensure that you've fully verified the interfaces. And we can do the same thing with our Veloce emulation platform. Just like Questa, Veloce can capture functional, code, and assertion coverage into the UCDB. In fact, other than a field in the database that indicates what test and what platform was used to capture the data, you can't tell whether the coverage came from the simulator or the emulator. Now, the way we capture the coverage in the emulator is to actually synthesize the corresponding logic to record the cover points and assertions. So just like Questa, Veloce can look at the current coverage and use that to optimize the synthesis process so we don't generate the extra logic to capture coverage that we've already reached. You also have the choice to synthesize the logic, but to enable or disable the coverage or assertions dynamically. So we've got that going for us, which is nice. And we can capture the analog coverage too from our Questa ADMS analog mixed signal simulator, whether it's code coverage, analog assertions, or even SPICE measurements, into the same UCDB. The feedback loop for analog isn't quite as automated as for the digital side, but you can still see your coverage in our verification run manager environment and use that knowledge to disable checking on coverage that you've already reached. When we bring power into the mix, there's literally another layer of things we have to worry about. Our Questa power-aware simulation platform will automatically include the power control, isolation, and retention logic from your UPF description, and it will let you see how much of your power control logic you've covered. You can get a quick look while your simulator is running, and all of the data on power state coverage and power-aware assertions gets dumped into the UCDB like everything else. And we can also auto-generate a power-aware test plan based on your UPF description. And this also gets put into the UCDB like our other test plans. From there, it's a straightforward step to convert that into a standard test plan format using our Excel add-in for test plan editing. And you can insert that into your top-level test plan, so now your power-aware test criteria are embedded, managed, and tracked along with all the other elements of your original test plan. Now, it's very rare that everything gets covered in the first shot, so we need to fill those holes. Think of Questa Cover Check as your shovel. It takes the coverage data and looks at what hasn't been hit yet. The first thing we need to know is whether any coverage hole is even reachable. If you've got a hole under the porch, you don't have to worry about anyone falling into it. Cover Check's formal analysis, which is automatic so you don't have to worry, will show you which holes are reachable and which are not. For those holes that are not reachable, Cover Check will automatically generate exclusions for those elements in your coverage so you don't have to worry about them anymore. For those that can be hit, Cover Check will generate what we call a witness waveform to show you how it could be hit. Now, since Cover Check is looking at a certain window of time on a small part of the circuit, this waveform will show you how the particular element could be hit, but it's up to you to write the test to get there. Now, it's possible that in looking at the witness waveform, you'll see that it generated a waveform that you think it shouldn't. The first thing I'll say is that the tool is right in that the waveform is possible even if you think it's not, given the subsection of the design it's working on. If you're comfortable with assertions, you can add some assumptions to tweak the witness waveform. Then you just bind these new assertions in with your design and rerun Cover Check. This what-if analysis in Cover Check is still much faster than simulation in most cases, and may find even more uncoverables. Cover Check is the embodiment of the 80-20 rule. You catch 80% of your coverage in simulation or emulation, and then instead of trying to create tests for the remaining 20%, we check to see how much of that 20% is even reachable. Every test you don't have to write is a win. Depending on the size of your design, Cover Check can save you months of effort. Of course, Questa Formal supports several different static analysis tools that complement your simulation. The first is Questa Prop Check, which lets you write your own assertions and check them against the design. I won't go into all the details of how formal verification lets you prove that certain properties will always hold about your design so you don't have to simulate them. Let's just assume that's true. The way we take advantage of that from a coverage standpoint is twofold. The first is that the assertions themselves are covered and recorded in the database. But we've recently added a new capability on Prop Check. It can now do the equivalent of code coverage, including statement, branch, toggle, and all the other types of code coverage for all of the RTL that affects the fan-in of a given assertion. It also can target cover groups that are in the fan-in of a property as well. So after you run your formal, you know in the coverage database what things you still have to target in simulation. And as we said earlier, Questa can use the UCDB to optimize the simulation so it won't bother simulating cover groups that were already covered with formal. Again, any test you don't have to write runs infinitely fast, so that's a win. By the way, Prop Check can also do reachability and observability analysis under the hood, so it can tell you where you need to add more properties if you want to use formal to cover more of your design. Questa CDC will check all your clock domain crossings for you. Any properties it covers will automatically get put in the database, but it also identifies all of your CDC issues and automatically generates a CDC test plan that goes into the database as well. One of the things that CDC does when it sees a potential problem is to inject metastability models into the RTL. These models will inject random delays at clock domain boundaries and create assertions to make sure that the delays don't break anything. These assertions get automatically recorded in the UCDB as well. Questa Connectivity Check is there to make sure that things are connected correctly. It's basically a much simpler subset of Prop Check, where it lets you write simple connectivity assertions, like when select equals A, the input pin should be muxed to mod A.pin1, otherwise the input pin should be muxed to mod B.pin1. These assertions can be proven just like Prop Check, and if there's a problem, we'll show you. Connectivity check will also create a test plan for these assertions, which are actually generated from a much simpler input format. And lastly, Questa register check does the same thing for your registers. With simplified assertions about the register behavior, we put the assertions in the database and auto-generate a test plan. So all of our Questa formal apps know about the UCDB, and they can all generate test plan snippets for you so you can track them along with everything else in your test plan. Just like Questa and Veloce, Catapult coverage provides high-level synthesis-aware code coverage, including statement, branch, FEC, toggle, and array access coverage for C++ and System C high-level synthesis designs. It also provides System Verilog-inspired functional coverage with support for cover groups, cover points, bins, and crosses within C++ and System C test benches. One of the primary motivations to use Catapult coverage rather than, say, gcov or lcov is Catapult coverage is HLS synthesis aware. This means that unlike gcov and other software-centric code coverage tools, Catapult coverage is aware that inline functions will be unique instances in post-HLS RTL, and thus reports coverage on a per-instance basis. Initially, HLS uses pragmas to guide the HLS process, such as the unrolling of loops in HLS design source, which result in multiple unique instances for each iteration of the loop. Catapult coverage is aware of directives such as these, and so it reports coverage for each iteration of an unrolled loop. These approaches result in coverage more closely aligned with the code coverage that will be seen when applying the same tests to post-HLS RTL. Yet another reason is the coverage is saved within a UCDB, thus providing a rich set of verification management capabilities for generating reports, analyzing results, applying exclusions, merging and ranking of tests, and other things. Yet with an HLS design as the DUT. And you can view Catapult coverage results for both code and functional coverage in an HLS context. Last year, we introduced our visualizer debug environment, and a big part of that was to make coverage easier to analyze by integrating it into the debug process. We improved the GUI in a lot of ways, especially making it easier to manage exclusions and to navigate through your coverage, and through the design in general. Coverage data has been growing for a while, so we built it to have better capacity and performance to handle really big designs. For the first time, we combined coverage analysis and debug in a single tool. With the waveform and design data already in Visualizer, we're able to leverage that information to help you see your coverage results in context. We've talked about the necessity of having a verification plan, and we've integrated that into Visualizer. So we link verification requirements to specific coverage items in your verification environment. From there, you can analyze and filter the results as much as you want. We'll see in a minute how this works, but one thing you'll notice is that the navigation through the design is structural. It's based completely on the hierarchy of the design and the test bench. So when we look at our coverage results, we can look at results for our calculator block and expand that block to see how we're doing with each type of coverage for that block. Then we can look more closely at the code coverage results and see that there are a couple of branch coverage problems. And we can click on that and go straight to the line where the problem is. And in addition to navigating the coverage in this way, you can easily go from your coverage view to a waveform view to see and debug why the branch isn't actually covered. At this point, I'd like to hand things off to my colleague, Athira Paniker, who will walk us through a demo of how to visualize, analyze, and debug your coverage in Visualizer.
Here I have invoked Visualizer in coverage view using the -qgov command. The coverage view opens up the design hierarchy window by default, along with the source code window. And I also have the test plan tracker window here. You can see the section operand limit and the assertion that we covered previously. All the coverage windows can be accessed from the toolbar here by clicking on any of these icons. Or like I mentioned before, you can go to View, Coverage and click on any of the coverage windows from here. Now, since we already saw the assertion coverage window, code coverage outline window, and coverage details window, let's have a look at the cover groups window. The cover groups window opens in a split view, like shown here. On the top pane, you have the name of the cover groups and the coverage details like miss bin, total bins, coverage percentage, etc. And on the bottom pane, you have the bins and cover points related to the respective cover groups that is being selected. For example, I'm going to analyze the opcode combination cover group from the top pane. So double-clicking that will show the cover points and crosses of the opcode combination cover group. And if you expand the cover points, you can also see the bins associated with the cover point. And here you can see the bins associated with the crosses as well. Also, in double-clicking the cover group, it also highlights the cover group for me in the source code window. And if you double-click the cover points, it also highlights the respective cover points in the source code window. The table also shows the status of the cover points or crosses that are not covered. For example, here we have cross opcodes, which is not covered. So I'm going to sort this to see the uncovered bins first, and you can see and analyze the cross to find out what's not being covered. And like all other coverage windows, the cover group window also has an option to filter by cover group names or filter by coverage percentage. You can also do that for the crosses and cover points pane as well. Visualizer also has FSM coverage window where you can analyze the transition coverage and state coverage of FSM. Here you can see in the design hierarchy window for the key instance, we have some missing FSM transition percentages here. To analyze this, you can go to the toolbar and click on the FSM list icon. That will open the FSM list window. The FSM list window will show you all the FSMs in the design. So you can see that the first FSM here is for the instance key, and that has a transition coverage of 71.42. So if you double click this FSM from the list, that should open up the FSM coverage window with the state diagram, and also it should open up coverage details window for the FSM. If you look at the FSM coverage window here, you can see the states and transitions. The states are all green, so all these are covered, but there are some transition coverage that is still missing. So you can zoom in by using the scroll button on your mouse, or you can also select and zoom in a particular area. Or you also have an option to click the zoom in or zoom out button here. Double-clicking the FSM state has also opened up the coverage details window with the details about the transition coverage and state coverage. You can see we have 6 states here and the state coverage count as well as the transition coverage. You can also see that there are some of the transitions that have missing coverage. Those are also highlighted in red in the FSM coverage window. So we have a transition coverage of 71.42. Now, if you go back to the FSM coverage window, let's have a look at the state transition from S6 to S5, which is not covered and has a count of 0. So I'll be double clicking that. That should highlight the line where this transition is missing, which is line 106. Also, if you look here, the line 106 has a statement coverage miss, meaning this else condition was never hit during the simulation. Also, this is an unwanted line of code because For the design, by the time we reach the state S6, row underscore n is never going to be a 0. Also, if you see on line 103, there is a condition coverage miss as well. So if you view the details for that, you can see that the condition being true is hit, but the condition where it's false is not hit. And it's not going to hit because of the way the design is. So this if statement here needs to be removed, and once we rerun it without the if statement, we can get rid of this condition coverage miss as well as the branch and statement coverage miss. And also the FSM transition will not be a miss, since there will not be a check for a transition from S6 to X5. For this demo, I'm going to go ahead and exclude the transaction from S6 to S5. To do that, I can right-click on the transaction and then click on Exclude Selected. So that should add the coverage exclude command for excluding the transaction to the pending exclusion window. From the pending exclusions window, you can execute this command by selecting it and clicking on the green icon here. That will exclude the FSM transition. As you can see, it's grayed out. All the exclusions that are executed from the pending exclusions window is added to the exclusions list window. You can go to the exclusions list window from the toolbar, clicking on this icon here, or you can also go to view coverage and open the exclusions list window. If you look at the exclusion list, you can see all the exclusions that were executed before. Here is the FSM transition that was excluded, and this is the condition coverage, the row that we excluded before. This exclusion list can also be saved into a do file, which can be used later on. To save these exclusions into a do file, you can select all and click on Save Exclusion File icon and save it with the name. I'm going to go ahead and save it as exclusions.do file. And like I mentioned before, you can also save the exclusions once you add the exclusion to the pending exclusions window as well. And if you want to load an exclusions file that was previously saved, you can click on Load Exclusion File icon from here and load the exclusion.do file. That loads all the exclusions back for you to the pending exclusion window. Now, if you want to remove any unwanted exclusion commands from this window, you can do that as well. You can select the exclusion that you want to remove and click on the Remove Selected Commands icon. That will remove the exclusions from the pending exclusions window. And to cancel an already excluded item, for example, the FSM transition that we excluded before, you can right-click and then select Cancel Selected Exclusion. So that will again be added as a coverage exclude command, but this time with the -clear option or switch to clear that exclusion. So to execute this command, you can go ahead and again click on the green icon here. So that should clear the applied exclusion for you. You also have an option to cancel exclusions from the exclusions list. You can cancel all the exclusions that were applied together by selecting all and then clicking on the cancel selected exclusion icon. So that will again bring back those exclusions to the pending exclusion window. Each of it will have a -clear switch, and then you can click on the green icon again to execute it.
Thank you, Athira. So, as you can see, Visualizer has some great features for helping you debug your coverage right alongside your regular debug activities. But as the challenges we talked about earlier are becoming more and more of a challenge for more and more design and verification teams, we at Siemens realized that we need to take the next step So for the rest of this session, we'll be introducing you to our new Coverage Analyzer tool, which offers unique ways of navigating your design based on coverage, not just the structure. And we'll also see how we bring in more collaboration to provide team-based workflows for coverage. So just to put things in perspective, our Questa verification management environment was introduced over 10 years ago as a modular single-user system that has coverage analysis, verification planning, and regression running. There is core functionality based on the UCDB used by many of our customers to build and manage their verification processes. As we've discussed, solutions need to have multiple engine and agnostic support, so interoperability is extremely important to many of our customers. We see many users attempting to build metric-based platforms and dashboards, and they want more visibility and predictability within their environments. Functional safety is cementing the need for traceability, requirements management, and links to lifecycle management. Collaboration is a natural need for a team-based process with multiple locations, projects, and teams needing central storage. Software development has had many innovations for productivity over the years, from the early years of machine code to higher level languages to methodologies like Agile and continuous integration. The semiconductor design process has mirrored that of software development for many years, lagging in the time it takes for the EDA industry to build tools to improve abstraction and process. Lifecycle management tools are a natural fit for functional safety traceability, and we're starting to see users turn to these solutions to manage requirements for both software and hardware. Emerging technologies like data analytics and machine learning bring the need for a platform with centralized data management and storage. And finally, cloud-based systems that allow for peak usage of EDA tools are becoming popular with some users. This will become more and more popular as we see IDEs and tools going to the web, which seems a trend in software development and all other tools. There's an overall trend of seeing software-based IDEs going to the web and the cloud, so there's a good chance based on history that we will see a similar wave within hardware design at some point. We want to target this as well as emerging technologies such as machine learning and data analytics, so we continue to be well-positioned to support you into the future. All of these requirements create a massive opportunity for us to provide a next-generation verification management and coverage solution, which you'll see shortly. This all makes sense if we take a look at the typical design process. There are multiple stakeholders involved in the design and verification process today. HDL and HVL code is developed and verified in a team-based environment in the majority of our customers today. Code is added, removed, and modified, and issues are tracked using an issue or bug tracking system. This is all pretty normal. If users have project and requirements management tools, these are also normally enterprise-type tools available to all stakeholders beyond the design and verification engineers. One of the great advantages of now being Siemens is that we are fortunate to have a tool like Polarion that provides all the lifecycle management features for collaborative project and requirements management, and that's just one of the many advantages we have now that we're Siemens. There's no reason why this idea of collaborative project and requirements management shouldn't be extended to the process of test plan or verification planning. Safety critical flows are very much connected to the requirements process, and having a similar tool to allow the verification plan to be created and managed would improve traceability and communication. Often, the verification plan is the starting point for customers who do not follow a full requirements-based flow, improving the plan-based flow also. With the test plans managed within a central repository, it allows historical access to data that would otherwise be lost. The same goes for regressions. Continuous integration solutions like Jenkins are already available within the web browser and therefore are available on an enterprise-wide basis. They keep track of the point at which regressions are run, whether periodically or triggered by source code changes. But again, Masses of data are produced with each regression, and having a central storage solution allows historical and collaborative analysis of this data to help turn it into information that's normally lost. There are also many other sources of data in the verification process. These include software licensing usage, compute resources, and the load-sharing software that controls where jobs are run. All of these systems are different, and users have many different combinations of these tools. Providing a data platform would allow all this data to be stored in a central repository from all of these different sources. This platform then lets you turn all that data into information by supporting everything from data analytics and cross-metric analytics to machine learning and more. Again, this data is typically lost because it stayed within its own domain or maybe wasn't even captured. And if you don't capture the data, you have no chance to turn it into valuable information. Providing a platform like this with technology that supports the web and enterprise-level applications also means it is constructed in a way that it will be possible to provide the solution at your site, on your intranet, or in the cloud. Questa Verification IQ is the next generation verification management platform implemented using web-based technologies. A web-based platform allows us to move towards use models that we have not supported with our traditional tools. It's a platform that allows us to support central storage of data and bring team collaboration to the verification process. The common services and storage within the web-based platform allow us to build various related applications which can interact with each other. This platform could be installed to use within a small group or on your intranet or even in the cloud as software as a service. On top of this platform, we are building applications to manage the verification process and its associated data to turn that data into actionable information. The first is Test Plan Author, a guide to the process, whether it's plan-driven or requirements-driven verification. We'll cover this application in more detail in the coming slides, but this is what gives us our opportunity to integrate verification with Siemens lifecycle management tools like Polarion. Regression Navigator allows regressions to be created, managed, executed, monitored, and analyzed, and is focused on reducing the turnaround time as much as possible to help you uncover defects. We'll talk more about each of the applications a little later in the session. Coverage Analyzer brings the industry's first collaborative coverage closure tool with the ability to analyze the coverage model in unique ways that augment normal structural analysis used by traditional coverage closure tools. Verification Insight introduces a metrics platform that many of our users have tried to develop themselves with scripting and open source software. Verification Insight is a web platform with central storage of more than just coverage metrics. It includes the ability to extract and store other verification metrics, letting you get closer to the visibility required to make decisions during the progress of your verification process. And lastly, Quantifier brings the future of data mining and machine learning to Insight and the rest of the platform. The promise of machine learning cannot be realized without a platform, and Verification IQ gives us that platform, enabling you to take the journey from descriptive analytics through diagnostic, predictive, and final prescriptive analytics for any of you that follow big data-fueled analytics. So now that we have a platform that holds more relevant data, we have the opportunity to improve optimizations in a number of areas of verification. And we'll talk about a few of these as we go through the rest of this tutorial. So going back to the vision diagram, we can see how this new platform fits together to provide the complete solution. The platform has central storage and services to serve all applications. First, Polarion is an application lifecycle management tool that was originally designed for software, but delivers many features applicable for hardware design and verification, including, importantly, requirements management. But it also provides issue and bug tracking, links to source code management, agile methodology support, and project management. Test Plan Author provides collaborative test plan creation for plan-driven verification, and with Synergy creates the ability to provide a complete requirements-driven verification flow, as well as a solo plan-driven methodology that can be integrated with other requirements tools. Regression Navigator provides regression running with links to continuous integration like Jenkins. Coverage Analyzer is our collaborative coverage closure tool. And finally, Insight and Quantifier provide the metrics dashboarding and data analytics platform that ultimately turns all of these mounds of data into useful information. Polarion IC Verification Assistant is the first phase of this requirements-driven verification vision. It allows the team-based capture of both the design and test plans within Polarion, and it allows you to import the coverage model from a UCDB into Polarion. It also provides an assistant to select the objects that should be linked to the test plan. Once the test plan is created, the test plan UCDB can be exported directly from Polarion to drive the rest of the Questa verification management process. Results can then be imported back into Polarion to provide the traceability between your design, your test plan, and your verification results. IC Verification Assistant provides the templates to define work items in Polarion that allow verification requirements to be captured within a test plan. These work items can then have any user-defined workflows supported by Polarion. The Verification Assistant allows a UCDB to be imported so that the user is presented with the coverage objects to link to verification requirement work items, and then export the created test plan. And finally, with the results exported back into Polarion, traceability reports for both implementation and verification can be viewed, or you can generate automated reports. Coverage Analyzer is the first application that we have released within the Verification IQ platform, our next generation verification management platform. It is a unique coverage tool supporting collaborative closure processes out of the box. It's been designed using user experience techniques and has been architected to improve a number of the tasks that had become difficult on the desktop in older UI toolkits. It is completely consistent and backwards compatible with the UCDB, so it fits straight into the existing verification management flow. Having been designed using a web-based platform, it is both device and OS independent, allowing the use of Apple and mobile devices like the rest of the platform. Coverage Analyzer's strength is its ability to provide a team-based shared environment for coverage closure and analytics. Customers have already been getting excited about these new use models, like enabling the opening of a regression UCDB after the regression overnight so that it is ready for the complete team to start analyzing in the morning without multiple tool startups. This is on top of the benefits of collaboration introduced by having a single data source being updated by multiple users, sharing views, URLs, exclusions, and everything else. It integrates without context changes to all the other collaborative applications that make up the verification process, not just the other Verification IQ applications, but all of the other enterprise tools in the flow, like source code management, issue tracking, and requirements management. However, we still ensure that there are tight integrations to invoke desktop debug using Visualizer on the same instance, DUT, and or test case that you're analyzing in Coverage Analyzer with a single click. On top of that, the restrictions on navigating the coverage model by instances and design units is augmented by the ability to use analytics to see bin distributions and heat maps at all levels. It also benefits from a number of patented technologies using network graphs to analyze cover groups and do deeper analysis of expressions. Advanced analytics and data mining are being used to help you reach coverage closure. So Coverage Analyzer provides collaborative workflows in a team-based environment. Using web technology means that it has been constructed to take us seamlessly into the cloud, but also supports single and multiple location collaboration on internal networks. Coverage Analyzer is the gateway to the rest of the verification management platform and multiple closure metrics. It's a modern UI with performance and capacity for future designs with the platform independence to support any device running a browser. We provide top-level summaries of coverage model and metrics along with heat maps and distribution graphs, which give the user a better insight into their coverage. Heat maps take you straight to the hotspots of your design, and bin distribution indicates the areas that can be targeted to improve coverage numbers quicker. We've used a patented analysis technique to help with the analysis of metrics like expressions to again help with closure. The expression analysis carries out pattern matching within expressions to help the user understand common expressions within their design and assist with exclusions and closure. It helps by grouping expressions with common terminals to help apply multiple exclusions or figure out what is needed to hit multiple expressions to improve coverage quicker. We've also patented the use of network graphs to show relationships between cover points and crosses, as well as whole and cluster analysis. It allows views of what-if analysis when targeting certain parts of the coverage model. It also allows the ability to apply transitive exclusions to ensure excluding a certain cover point will exclude the crosses as well. Here is an example of the Coverage Analyzer dashboard, which is the first page you see when you first load the tool. You'll see more specifics on each of these items as we go through the demo, but to quickly highlight some of the items, at the top, you'll see the test summary, which shows how many passes and failures you had. On the left is a high-level summary of the coverage achieved thus far, broken down by coverage type. The top right here is showing a breakdown of cover group coverage, which allows you to quickly navigate to problematic cover groups directly from the dashboard. In the middle is a bin distribution, which shows not only the coverage of given types, but also the bin counts in reference to each other, and gives you the ability to drill down into a given coverage type to investigate the coverage holes of that type. And lastly, at the bottom, you see a design unit heat map, which shows you the top 20 design units which are negatively impacting your coverage at the moment. If you want to make the biggest impact on your overall coverage numbers, these are the design units you'll want to focus on. In addition to many new ways of analyzing coverage, there's also some familiar means of coverage analysis in Coverage Analyzer. Here you can see the typical structural analysis, which allows you to sort and filter for any particular hierarchy you're interested in analyzing. There are also many different ways to change the display so that you can get the view you want, whether that's via a flat list, a hierarchical list, by instance, or by design unit. You can choose whatever you want. You can also leverage some of the same visualizations from this page as well to allow you to focus on a given section of the hierarchy, and the graphs will adjust to only target those selected sections. Similarly, there's also a familiar but vastly updated source code analysis view. Here you can see coverage annotated on your source and filter by coverage types. You can also get a list of all the coverage items in a given design element, search for misses, and apply exclusions from any window. There are also several new analysis features that Coverage Analyzer provides to better let you understand how coverage is connected and focus on common problems rather than tackling everything at a single bin level. But rather than try to describe all the new features that Coverage Analyzer provides, I think it would be better to just show you a demo of a few of these new features. So now I'd like to call on my colleague Tom Ellis to give us a brief demo of Coverage Analyzer.
Thanks, Tom. I'm going to take a few minutes here just to give you a quick tour of some of the features within Coverage Analyzer. Like Tom mentioned, this is what you see when you first load the tool, which is the home dashboard. We have a summary of all our coverage types over here. We have a bin distribution graph, which gives us an idea of not only what's covered and uncovered for a given type, but if you want to drill down into that to find out where your biggest problems areas for a given type are, you can quickly navigate to those areas as well. We have this coverage group distribution graph also, which lets you see where your cover groups are in terms of coverage. So if I'm just interested in finding my least covered cover groups, this gives me quick access to that list. And then finally at the bottom is the design unit heat map. And what this does is it goes in and looks at all the design units within the design and looks at how much coverage it's contributing, how many bins are missing, and nominates the design units that are most negatively impacting your coverage. And so you can think of these kind of being ranked from left to right, where the size of the block represents how many missed bins there are for coverage, and the color of the block represents the level of coverage, so red obviously being the worst and green being the best. And what this points out is something that may not always be obvious, which is that the blocks that could be most negatively impacting your overall coverage metric, and when that I'm referring to this total coverage number up here, are not always the blocks that are red or have the least coverage. They can actually be blocks that are covered fairly well, but because they're so large, they're actually the ones that are causing the biggest issue. So this gives me an easy way to see that, and again, I can just navigate directly to that instance from here. We'll get back to that in just a second. And lastly, the other thing I can do is if I know exactly what I'm after, I can always just click the search button up here, start typing in what I'm looking for, and it will populate with the given items which match, and clicking on any of these items will take me directly to that particular object. In addition to using some of these charts and graphs to be able to quickly get to what we want to analyze, we still have some of the similar design instance and design unit structural views that you're used to. So I can come in here and look for a given design instance. You have the ability to sort, search, and filter for whatever you're interested in. Or if you wanted to, you can do the typical, just expand down until you get to the particular area that you're most interested in. One unique thing that you can do here as well, though, is let's say I'm only interested in a particular sub-hierarchy of the design. What I can actually do is use this little graph icon here. And what this is going to do is, rather than what the graphs are right now, which is exactly the same as the dashboard, in other words, it's taking into account every bin within the design, I can tell it to scope that analysis down to just this particular area of the design, so here recursively downwards. And it will change these graphs to give me a better idea of, in this region of the code, where my problem hotspots are. So if I were to come down to this design unit heat map here, and I'll pick a particular instance to go and analyze, we can go navigate over to that. Here you can see the source code that's annotated with coverage, as well as the outline window, which gives you a list of all the coverage in this particular design unit. So this is showing you all of the coverage types that are in here. There's also the ability to filter. If you only wanted to look at, say, statement coverage for a particular block, you can turn on this filter. And now we're only looking at statement coverage in this design. And you can see again now the source code annotation is only affecting the statements of the design. When no filters are on, I'm looking at everything. I also have the ability to filter what I'm looking at. So for example, if I was only looking for the misses, I can quickly get access to what those misses are. You can see a lot of my toggle coverage misses up here, statements, branches down here. And both of these windows are contextually linked together. So if I click an item in the outline window, it will show me that particular line of code over in the source code. And vice versa, clicking a line in the source code will take me to that particular line within the outline window as well. One of the really nice features is you can do exclusions from virtually anywhere in the design. I can simply select this block of code, for example, and I can either right-click and say exclude, or I can use the exclusion icon buttons up here. Let's say I wanted to add a comment down here, and click add comment. And what that does is it will file that exclusion away down into my exclusions over here. And so what you're looking at here is a list of pending exclusions. So these are exclusions that I bucketed to say I want to exclude these items, but I haven't actually gone through the course of excluding them from the database. You can tell that they're pending both by being existing in this pending tab, as well as by this unique exclusion icon up here with a little clock to also signify that those are pending exclusions. Down here, you can see that there's various types of coverage that have been excluded, And you can also see that when I just excluded those 2 lines up there, I actually ended up with 3 different exclusions. And that's because this particular branch up here also includes a condition. And so by virtue of excluding those from the source code, it excluded every type of coverage associated with those lines. If, for example, I didn't want to exclude one of these items, I could also just come in here and click the little trash can, and that will remove it from the particular list. As you can see right now, I currently don't have anything that is actually excluded. And as I go in here and click the Apply button, this is going to apply all those exclusions that I have set up in my sort of shopping cart here. One of the nice things is while these exclusions are applying, the entire tool remains responsive. I can go in and continue the analysis of what I was doing. And once those exclusions are done, I'll get a little pop-up up here in the top middle. You'll see those exclusions just increased my coverage by 0.2%. There was only a few exclusions there, so I wouldn't expect a large increase. But that allows me to be able to notice immediately what that increase was, rather than having to remember what those coverage numbers were. One of the other unique things we do in terms of more advanced analysis features within Coverage Analyzer is around the recognition of common patterns that exist within your condition and expression coverage. So right here in this Patterns tab, you can see a list of common patterns found across this particular design unit. Now, these are cases where either the condition or expression has exactly the same set of inputs. Sometimes it might be 3 out of 4 or 2 out of 4. And you get a breakdown based on how much it can find a commonality. So in this particular bucket up here, I have 10 expressions that have a similar input term and then a sort of similar expression that follows it. And the further we drill down in here, if I'm to double click on this one, you'll see the expression tree and the particular expressions that make up this particular set of conditions. So I'm just going to expand this to get a better view of what we're looking at here. On the left-hand side, you see the tree, which represents all of the signals that are applied in this particular expression, how those are related together, and how those have to be evaluated to trigger the result of the expression. On the right here, you'll see a table which is showing all of these expressions that are fairly similar. You can see in a lot of cases where we see an actual name, this is the actual terminal name themselves, and in most cases they're very similar. In fact, these top 4 are remarkably similar, especially in the sense of how they've been covered. So one of the unique things I can do is, in this case, right, they're not things that you would normally see within even the same window while you're analyzing your code. What I can go and do is select these 4. So now that I've got those 4 particular expressions selected, let's go in and look and see why they're not being covered. And so here I'm looking again at all of those expressions together, and what you can immediately see is that all 4 of them are presenting a value of 0, but none of them are ever presenting a value of 1. And so that's clearly why this particular term is not being covered. And if we take that expression and we look at where it resides in the expression tree over here, what you'll see is that that actually goes into an AND operation. And given the fact that if this is always going to evaluate to a 0, this is always going to evaluate to a 0, which means I'll never be able to cover these particular terminals, as they'll never have control over the entire expression. So what that means is either I'm not giving the stimulus that I need to be able to set this value to a 1, or perhaps these are unreachable conditions and I shouldn't be able to get to these either, in which case I can go in and I could selectively exclude these entire terminals if I wanted to as well. So it's just a really good way of being able to not only visualize your expressions, but also be able to quickly analyze larger groups of them. So you're not looking at a per bin basis or even a per expression basis. You're looking at things in a larger scope and finding those commonalities. And so you can see here that both those terminals have been fully excluded. In addition to applying the exclusions, one of the other things we do is keep track of who applied the given exclusions. So here I can see that both me and a few of my teammates have actually applied exclusions to this. I can get access to those both from this smaller exclusions tab at the bottom, but also from the proper exclusions window here via the tab on the top. Here I can sort and filter based on the exclusion types that I have. I also have the ability to either import an existing exclusion list file, which would be like a do file, a typical do file that you're used to with Questa, Or I can also export this list out to a do file if I wanted to, say, check that into revision control or put that into some type of a regression script to automatically apply these exclusions on the next regression run. I can do that all directly from the exclusion dashboard here as well. You can also see who excluded them. So for example, if I was only interested in the exclusions that I've done, I'm able to type that in and I can see exactly what exclusions I'm responsible for in the design. So this is a really nice aid for being able to not only keep track of who's done what, but be able to do that as part of an exclusion review flow in understanding why things were excluded and what other impacts they may have on the design. Not only can I see who's applied exclusions, but since this is a collaborative mode, I can also see who's actively analyzing this database. In this case, it's just myself, but as other users log on, this list would start to populate with those particular names. Oh, as you can see, it looks like Mark just jumped on, in fact. Oh, I just saw the pending tab flash, which means he's applied a couple exclusions there. So it looks like Mark's found a few cover directives that he also wants to exclude. So you can see there how it's pretty easy to be able to keep track of what everybody's doing and be able to collaboratively work on the same database at the same time. Since this is a web-based application, you can also share this URL with anyone else in the team. They can log into the system and they'd be able to see exactly what I'm seeing. I wouldn't have to give them the exact steps to repeat to reproduce the exact view that I have. It's just a matter of clicking a link, and as long as they have access to that project, they can go in and analyze that coverage. And there's also some test analysis features. For example, here you can see a list of all of the tests that I have within the design and some of the high-level attributes associated with those tests. So like the name of the test, what seed values were used, whether or not those tests passed or failed, how long they ran for, and so on. So one of the things I can do is set up different types of ranks. We call them a rank configuration, so that I can easily return to those later. You'll see that I have one here already, but let's create another one just for the fun of it. I'll just call this one demo. Can give it a description, and I can selectively choose what coverage types I want to rank on. Let's say maybe I'm only curious about code coverage in this particular case, and click rank tests. And that will rank the tests and show me what tests contributed and did not contribute to code coverage. And I can quickly just filter down to look at only the contributing tests. So here I can see a list of those tests, and I can also enable the coverage feature so I can see what coverage each of those tests contributed. For example, this first test was able to get me all the way to 33.79% coverage all on its own. Adding in this next test gave me almost another 2%, and you can see as I go there's some diminishing returns until I get to this final test. That's the total coverage of that given test. If I scroll over, you can start to see what types of coverage were improved for each of those given tests as well. So you'll see some tests may have contributed to multiple coverage types, some tests may not have contributed to a given coverage type. So via the ranking, I can use that capability to also understand what tests are better affecting particular coverage types or areas of my design. You can see I can also quickly switch and back and forth between particular configurations that I may have set up, and if I want to just get back to my original list, I can quickly reset as well. So some nice new unique ranking features to be able to not only rank and look at your tests, but be able to save those configurations so you can quickly return to them later. So otherwise, that's a quick overview of a few of the unique features within Coverage Analyzer. We obviously didn't have time to cover everything. There is support for functional coverage, cover groups, assertions, and directives. We also have full support for test plan coverage if you're using a test plan as well. Each of these with new and unique features and visualizations for analyzing and closing out on your coverage.
Thanks, Tom. We didn't really have time to go through every feature in Coverage Analyzer, so I want to just point out a few other key aspects that we weren't able to get into in the demo. Here you can see the cover group analysis page in Coverage Analyzer, where you will see several new analysis features as well. First, on the top left here, you see a similar coverage distribution chart that lets you see a breakdown of your coverage model based on how big the bin space is for your cover points and crosses. This makes it easy to identify the biggest bins that you have and see how your crosses relate to your specific coverage points. And you can filter this view by the type of element you're looking for. The top right is a really powerful feature which allows you to easily find the biggest hole in your functional coverage model. Coverage Analyzer analyzes all the crosses in your cover group and nominates the top hole that is most negatively impacting your coverage, and shows you a breakdown of the bins contributing to that hole, as well as what the coverage increase will be if you close that hole. And just beneath that is a network graph that shows the relationships between your cover points and crosses within a cover group. Cover points here are represented by circles, and the crosses are squares, giving you a visual of not only the coverage of those items, but additionally what the shape of your cover group itself is. And of course, you can navigate through your coverage directly from the graph to make it easier to find your way around. And lastly, on the bottom left, you see a more traditional list of all your cover points and crosses in this cover group, and you can again sort and filter to find any particular item you're looking for. This is similar to the view that we saw with Visualizer earlier, but here you can see that the information is presented in a more visually pleasing manner and is fully integrated into the overall coverage analyzer. Lastly, a quick look at test plan coverage, which is a crucial aspect of any coverage-driven methodology. Here you can see a summary of the test plan as well as a shortcut to get to the sections in your plan that need the most attention and are having the biggest negative impact on your overall test plan coverage. There are a few additional visualizations here as well, which show you a breakdown of coverage elements that exist in the design but aren't linked in your test plan. This typically highlights a problem or an item that isn't properly accounted for in your plan. Finally, Coverage Analyzer shows you a complete view of your entire plan and the associated coverage elements of each section. Again, with the ability to sort and filter to find the information you're most interested in analyzing, whether it's looking to get an idea of how you're doing on high priority items a given engineer is responsible for, or you just want to find a given section, you can easily accomplish that through the plan tracking table. So where do we go from here? Well, there are a lot of different kinds of data that are just waiting to be turned into information. Performance profiling is always helpful, both of your design and your test bench, so you can identify bottlenecks that might cause your regressions, and therefore your overall project, to take longer than is really necessary. You can also track your engineering resources so you can see if you have enough people working on the most difficult problems. You can also see if any particular engineer might have too much assigned to him or her, making them a bottleneck for your overall project. And if you track how long your regressions take and track them over time, you'll be able to be more predictable in forecasting how long it will take you either to rerun tests when a change is made or to finish a given regression run. And by tracking other aspects of each test, you can quickly identify the set of tests to run that will give you the best coverage in the shortest amount of time, which is great for deciding which tests to include in a check-in suite. And of course, we want to make sure that the design will ultimately operate as intended, so profiling DUT performance can help you find specific problems. We had one design we were analyzing with a prototype, and it reported a performance problem. There were some bus operations that took a really long time. They worked in the sense that the data was properly transferred eventually, but we were able to zero in on the problem, and it turned out that there was a bug in the cache controller. The long cycle time happened because the controller was getting confused and was just about to invalidate the data when another signal came in to reset the controller, which let it complete the operation. A little investigation showed that it was just a condition of the test that caused the reset to happen, and that in the real world, it would have been possible to incorrectly invalidate the cache. An incredibly hard to find error that could easily have gotten out to the field was identified and fixed because we were able to closely track the performance of the DUT. And as we move into more machine learning and other science fiction kinds of applications, our Verification Insight platform will be right there to help you keep track of all the data so you can maintain the quality and predictability you need even as designs get pretty wild. Of course, the first thing you need to be able to teach a machine is data. So we're getting you the data. We started with descriptive analytics, which let you know what happened. Some of us are old enough to remember when this meant poring over log files or waveforms to manually check that the test did what it was supposed to. Fortunately, we moved to self-checking tests, where what eventually comes out as a simple pass-fail message may involve some pretty detailed automated checking. Of course, self-checking tests are required as soon as you inject randomization into verification, which is pretty much a given, since there's not really a better way to model the fact that the real world in which our designs will have to operate is a messy place. From there, we moved to diagnostic analytics, answering the question, why did it happen? This is where we started applying automation and other techniques like signal tracing over time and pattern recognition, not to mention assertions, to figure out what caused the error to happen in the first place. But of course, data analytics can be applied to the broader problem of project management as well. Descriptive analytics would be your post-mortem report to your manager explaining that the bug closure rate dropped significantly last August. Diagnostic analytics would be you including in the report that the reason the bug closure rate dropped is that Steve went on vacation in August and no one picked up his workload. With the advent of big data, we get to start exploring new possibilities like asking, what will happen if I do X? This can be applied to both tests and to designs, and having all the data is what lets us scour the data we have to forecast the impact of certain decisions. From the specific verification perspective, this might mean, what will happen if I redefine the state machine, and allow you to predict the schedule impact by understanding the set of tests you'll have to rerun, the machines available, and even how much of the design is actually affected by the proposed change. From a management perspective, you could ask, what will happen to our bug closure rate if Steve goes on vacation again? And of course, the holy grail of verification is prescriptive analytics, where we define what we want to happen and automatically guide the tests to get us there. While I don't think we'll ever get to the point where you can have a test bench that just randomly starts throwing stuff at a design and magically tweak the constraints to reach your coverage, the idea that we can build from our one centralized database and information platform to be able to generate a specific test to close a specific coverage hole is not far-fetched. And for the project manager, you could look at past projects and say things like, Steve tends to take vacation in August, so we'll automatically reassign his tasks at that time to other members of the team. And since you have all the information, you don't have to randomly assign Steve's tasks. You could assign them to other engineers who have worked with him more closely, so they'd be able to be more productive in picking up his work temporarily. Who knows, with enough data, you might actually be able to predict Steve's vacation before he does. Coverage Analyzer and Verification Insight are the first steps on the way to a verification metrics platform for the purpose of giving you predictability in your verification process. As we've been talking about, it all starts with a centralized repository for all of your verification data and provides a platform to manage all that data. Whether we're talking about coverage data or other functional metrics from your regression suite, or process metrics from your requirements or verification plan, or your bug tracking or revision control system, you can now keep track of process level data in the same repository. And at the project level, you can track project resources, software licenses, and compute resources. With all of this data at your disposal, our unique data visualization capabilities let you turn that data into information. By letting you see more information about your verification, we can use data analytics to help you reach your goals faster. And all of this is just the beginning as we move forward with everything in place to be able to apply machine learning to help you along the way. We talked at the beginning about pain management. Verification Insight, starting with Coverage Analyzer, starts with a web-based, cloud-enabled platform to enable collaborative sharing of all data across your team, your company, or with whomever you want. The single UCDB repository has been architected and optimized to facilitate team-based collaboration throughout your enterprise. By tracking new metric data along with coverage, regression results, and all the stuff you've been doing, Verification Insight will let you get a handle on much bigger questions than just, did last night's regressions pass? And by applying data analytics, we saw how Coverage Analyzer gives you unique views into your design based on coverage results and not just the design hierarchy. And we saw how applying similar analytics to different kinds of data can help you achieve not only predictability in your project, but also the efficiency and effectiveness you need to make sure that you can answer the most important question, when are we done? And actually, we're now done with this tutorial. Thank you for your attention, and we'll be happy to take any questions.